What's going on, everyone? How's everyone doing? Hope you're having a fabulous afternoon, evening, or morning wherever you're tuning in from. My name's Miguel, also known as the Vegan Math Guy, and this is Tuesday's Integration Bee. What's up, S? So, as always, every Tuesday, Integration Bees. And of course, if you're watching this on a replay, it's going to be on YouTube. So, let's go ahead and just start with a very basic integral that I have a few of. And we can kind of get started and then warm ourselves up and then go from there. So let me just go ahead and write that on the screen. What's everyone up to? How was everyone's weekend? What's going on today? Curious to see what everyone is doing this Tuesday. Here is our first integral that we have here. And of course, as always, in the chat, let me know what you guys would suggest doing. Whether it's U substitution, integration by parts, partial fractions, whatever you think is best to solve this integral, I am all for it. This is a pretty basic one, I would say. And a lot of people might want to do U sub. Brandon, what's going on? U sub for sure. This is a little different, though. I'm not going to make U equal to x plus 1. I'm first going to start off by making our U is equal to root x. And then I'm going to square that so that we have u squared is equal to x. And that's going to help us out. So let's go ahead and take our du. We have 2u du, and that's going to equal to dx. And we're going to go ahead and rewrite our integral now in terms of u. So for the first one, we have the root x. That's just going to be u over. And then now we're going to go ahead and do 1 plus x. Let me just write 1 plus x for now, and then we're going to go ahead and rewrite that in a second. And then our dx, don't forget, is that 2u du. S, that's awesome. Yes, every Tuesday we are on here doing integrals. And of course, we are, I have some YouTube videos that you can cover, some TikTok videos. That's going to be fun. I'm so excited for your math journey. It's going to be a good one. I guarantee it. Okay, so all I did was multiply the 2u times the u, and now I have 1 plus x. So let's go ahead and talk about how the bottom is going to turn to. We have 1 plus x. And then now, check this out. This is why I talked about the u squared was equal to x, because we're going to utilize that. We're going to do u squared is equal to x. Let's add 1 to both sides. So now we have the desired x plus 1 on the left side and u squared plus 1 on the left side. I meant the right side and then the left side. Switch that up. How did you get 2u du? I took the derivative of u squared. So that's where I started off. Hope that makes sense at least. And so now we're going to rewrite the bottom. I should write my du. Can't forget that. So we're going to rewrite this as 2u squared over, remember the x plus 1 is now going to be u squared plus 1. And this is really neat because we still have that du. Brandon, take the derivative of both sides. Oh, you're trying to do some Feynman technique now. Katie, don't worry. Take it one step at a time. Okay, today's integration bee, so they might be a little more complex, but hopefully you get the gist of how to do u sub and so on. What's up, Burner? Okay, so we have u squared on the top, u squared on the bottom, and as always, one thing that we always said is that you can go ahead and use partial fractions because the degree of the top and then the bottom is the same. So whenever the degree of the top is more or equal to the bottom, then we can go ahead and use long division. So before I even do that, someone said long division, and that's why I did say, Gauss, yes, we can do long division. But check this out. I'm going to try to do something a little different. I'm going to pull out the 2 on the outside. And by all means, you can, and you should use long division. But I recently made a TikTok about this, and someone just recommended a different trick. Look what I'm going to add to that integral on the top, or the numerator. I'm going to add a 1, and I'm going to subtract the 1 at the same time. The reason being is because I can do that, because it just evens out the integral. But check this out. I have u squared plus the 1 minus 1 over u squared plus 1. And now I can separate this. So basically, I'm doing like a shortcut to partial fractions here just because I was able to identify the denominator looks very much like the top. So I'm going to separate this into two different integrals. The one that I circled there in green, and then the one that I circled there in blue. So this is what we're going to have. 2 times the integral of u squared plus 1 over u squared plus 1 minus 1 over u squared plus 1 du. Yep. Yeah, so it's like long division, but we're just going to go ahead. Again, we created a little shortcut here. Someone said, this is dope. I agree. And it's going to be arctrig or arctan. Yes. So that first integral is simply just u squared plus 1 over u squared plus 1. That's just going to be 2 integral of 1 minus 1 over u squared plus 1. And let's just go ahead and integrate this. We have 2 times the integral of 1 is just u minus, hopefully we can recognize that this is for Katie. I'm hoping, I don't know what level of integration you are now, but this is a very unique and special integral. That second one, u over u squared plus 1, is just going to be arctan of u, and you can't forget your plus c. Inverse tan, yes. Okay, so let me go ahead and make some space on the blackboard. If you've been on any of these streams or if you've seen these on YouTube, and if you are seeing it on YouTube later on, let me know in the comments. But you always know that we have to make so much space in the blackboard because these get crazy. So let me just rewrite our solution here. But the first thing I'm going to do, I'm just going to distribute that 2 into everything. So now we have 2u minus 2 arctan of u plus our c. And our u in the very beginning was just root x. So this is going to be 2 root x minus 2 arctan of root x plus c. There we go. Nice. A large function is sine of a square root. I actually don't have one like that today. Yeah, but we can try it out. We can play around with it. Yes, this is calculus. Oh, Dulahi, thank you. Thank you so much for the roses. Guys, if you want to continue supporting, subscribe for a month. Subscribe just a one time if you want to. But the more subscribers we have, the better of a community we can grow, and the more I can be on here to help you guys. Technically, this is Calc. You can say it's Calc BC because I think Calc BC students will understand this more, but it could be Calc AB. Arctan is tan inverse, yes. Okay, let me just start off the next problem, and let me answer some questions here. Free Math said arctan is the same thing as tan inverse. I agree, or at least that's the way I call it. If someone else has a different opinion, let me know. There we go, Daniel, thank you. Okay, so someone had mentioned, I can't see the username here. Maybe I could open it up. They had suggested, Alejandro Gonzalez had said, can we do one with the square root? Thank you for the roses. Can we do one with the square root inside? So maybe this isn't that big of a value, but we can go ahead and do x squared minus 2x plus 2. I don't know what the answer to this is. I literally just made it up, so I'm curious what everyone's going to do. IB Math, you know what? Later on, the more subscribers we can build in this community, the more people we can get, the more followers I have, I can go ahead and be live and answer questions like this. So I will take requests. I think later on we're going to do like a fundraiser, and you can send me all these math questions, especially IB Math, and we can solve them together. Okay, we'll do some with integration of parts after this. Okay, so Gal said, let's go ahead and complete the square. That's exactly what we're going to do. And by the way, I hate completing the square. I know it's super useful. I just don't like it. It doesn't look very good. So let's just go ahead and rewrite that. So x squared minus 2x. Don't forget, if we're going to complete the square, we have to take that b value. So in this case, the negative 2 divided by 2 and then square it, which is just going to be 1. So that's exactly what we're going to add when we complete the square. However, because we added or introduced the 1, we have to make sure we subtract the 1 to both. And now we can go ahead and factor out that part. That's why we're completing the square. And so now we're going to have x minus 1 squared plus, we're going to add the 2 minus 1, and that's just going to be 1. Oh, okay, this doesn't look that bad, though I'm kind of curious how that's going to turn. And I totally forgot my dx. Okay, so I completed the square. What's next, guys? What else can we do now that we completed the square? Oh, Jonathan said complete the square and cancel out the square root, but notice that we have the plus 1. We can't really do that. Okay, so let's go ahead and use substitution. Someone said make the x minus 1 our u. So that means du is equal to dx. I like that. Because now we can kind of just rewrite this, and it's a little cleaner. We have root u squared plus 1 du. That's not bad. Yeah, u sub. And then someone said u sub and then v sub. Ooh. I honestly do think this is going to be a trig sub type problem. I almost guarantee it. I'm just going to go ahead and create the triangle just to show you guys how this works. A lot of people already recognize this. We have u squared plus 1, so we can make our u equal to a arctan. Brandon, is this the Brandon that sent me that problem? Because hopefully now you're kind of familiar with it. So let's see. We're going to make our u our opposite. We're going to make our 1 our adjacent, and then we're going to go ahead and make our u squared plus 1 our hypotenuse. If you kind of follow along, this can be seen through Pythagorean theorem. Yes, calculus is worth it. I will totally suggest it. And to be honest, taking calculus, especially, I don't know what grade you're on, but I'm assuming if you're going to take it next year, I would suggest taking calculus AB. It's like a rite of passage. I mean, how many people in life would you know that said, yeah, I took calc in high school? Very few, to be honest. I know you might think it's a big pool, but it's actually pretty small. Going back to this, we can make, looks like tan theta is equal to our u, which we had said. So that means that secant squared theta d theta is equal to du. Hopefully that kind of helps us out. And then at the same time, we're going to have to say that secant theta is going to equal to our hypotenuse over adjacent. So that's going to be root u squared plus 1. And then now we're going to go ahead and rewrite this. Our integral is going to look like this. Now we have integral of the square root of u squared plus 1, that's secant theta, times our du, which is secant squared theta d theta. Oh, Alejandro, I hope you're still in here because you suggested this. Now it's going to get pretty nasty. So let's go ahead and simplify this. As you guys already know, we always have to make room for this. Now that I rewrite this, this is going to be secant cubed theta d theta. Does anyone know how we're going to integrate this secant cubed theta? Someone says substitute out the secant squared. Yes, absolutely. This is going to be one that we had done before, but let's go ahead and do that, especially what Brandon has suggested it. We're going to do secant squared theta times secant theta d theta. And now we're going to go ahead and use integration by parts. Slay, Brandon. There you go. Well, before we even do that, I think we can just go ahead and start doing integration by parts. Someone has suggested integration by parts, and this is what it is. So how about we make our u equal to secant theta? Our du is going to be secant theta tan theta du, or d theta, I'm sorry. Our dv is secant squared theta d theta, because we know the integral for that. That's just tan theta. Not bad. Okay. Let me, once again, make some space on the blackboard. Geez, this is such a long problem. We have yet to even find what the answer to this is, but let's go ahead and simplify. Let me write some stuff. Actually, I'll just continue here on the bottom, because now what we have is uv, so secant theta tan theta minus vdu, so tan theta, and then now we have secant theta tan theta d theta. And don't forget, this is still the integral of secant cubed theta d theta. We still need to solve for that. Looks like we're kind of stuck here because we still have that one integral, including the tan theta times secant tan theta. Any suggestions? I think we're going to have to just do u sub again. That's exactly what's going to happen. Though I don't know if that's going to be, oh, is that going to be good? We could do chain rule. Well, let's try it again. Again, it looks like we have to do another u sub in this same problem. So our u should be just tan theta. Our du is secant square theta, d theta. And then our dv is the remaining part, secant theta, tan theta. And the v is just secant theta. You're going to see why we're even doing this, okay? Because now what we have is we have secant theta. Oh, gosh, that's going to be actually just give us the same problem. Well, I always have an issue with this secant theta. Yeah, that's exactly what it is. Thank you, Sophia. Let's try that. Let me just erase some things. So Sophia's saying that look at the tan squared in that integral that we have. Let me just rewrite it. And we're going to rewrite that as secant squared minus 1. Yes, we need to add back over. I always do this to myself. I don't know why I do that. I always forget how to integrate this one. It's just a little tricky. But this is what Sophia said. I'm just rewriting this as tan squared secant theta. And we're going to use the identity. We're going to change this tan theta, or tan squared, as secant squared minus 1. This is one of the Pythagorean identities. Okay, and don't forget this is still secant theta d theta. And let me go ahead and make some space here again. And now this is what's going to happen. Thank you, Sophia. Saved us here. So if I rewrite this, I'm going to go ahead and distribute the secant theta. And that's going to be integral of secant cubed theta d theta plus integral of secant theta d theta. And this whole thing is still equal to secant cubed theta d theta. Whoops. And that integral, that secant theta, had to be cubed. Now, a few things that we're going to do. One, we're going to add this integral here to the other side. And it's going to make things very convenient. And so now what we have is we have secant theta, tan theta, minus, we technically have to integrate secant theta, and that is an integral that you should memorize. And that's just natural log absolute value of secant theta tan theta, or secant theta plus tan theta, I'm sorry. And then check this out. This is equal to 2 integral of secant cubed theta d theta. And now all we have to do is divide the 2 to the other side. So this entire thing, the integral that we were looking at, secant cubed theta d theta, is equal to this whole thing divided by 2, which is going to be secant theta tan theta minus natural log of secant theta plus tan theta, the whole thing over 2. It's a little sloppy, but let me go ahead and make some space on the blackboard, and now we can go ahead and rewrite it. Yes, I can definitely do a proof on that. We can talk about that. If there's enough people that want to see why the integral of secant theta is what it is, I can definitely go ahead and do that. And I can do it 2 ways. Okay, so remember we said that the whole integral, wow, this got like messed up here. Hold on, let me go ahead and go back. Let's go ahead and redo that. Okay, let me make it smaller. Here we go. Okay. So now we have our integral secant theta tan theta minus natural log of secant theta plus tan theta all over 2 plus c. But this is in terms of theta. We have to rewrite this in terms of x's. So if you recall from our triangle, I know it's a little blurry now. This is what we had. We had u as our opposite, 1 as our adjacent, and then we have root u squared plus 1. So now we can say that secant theta is equal to root u squared plus 1, which we kind of already knew, and tan theta is equal to just u. We can go ahead and rewrite this whole thing. So now this becomes root u squared plus 1 times u minus natural log of root u squared plus 1 plus u, the whole thing divided by 2, plus c. But this wasn't in terms of u, it was in terms of x. And I believe our u was x minus 1, so we just put an x minus 1 in for the entire u. Okay. So you guys can go ahead and do that. I'm just going to move on to the next integral because there's so many to cover. So let's go ahead and clear this real quick. All right, someone had said that they want to see the proof to secant theta, or I'm just going to do secant x dx, and why that's equal to the natural log of secant x plus tan x. Linear algebra, I could do differential equations. That's a whole different thing, but we can talk about that later on. We can definitely do a stream on that. So yes, Samuel has said the best way to do this, and I'll just kind of start introducing it, is when you take secant, what you can do is you can multiply both the top and the bottom by secant x plus tan x over secant x plus tan x. And you can kind of mess around with that. And if there, you can rewrite it. And that's what the integral of, that's what the integral will give you. Actually, let me just show you real quick. On the top, if we distribute the secant, this will be secant squared x plus secant x tan x all over secant x plus tan x. And technically, what you would do is you will make your u the entire bottom and the derivative of that. So your du is going to be the top. And from there, you can just say that the integral is just a natural log of secant x plus tan x. All right, guys, let's go ahead and move on to the next one. That one was a little dirty. It gets messy every time we have integrals or we have trig sub. It just gets super, super ugly. Never like it, but that's the thing sometimes. That's what we got to do. Okay, so how about this one? Let me go ahead and write this. Here we go. Any suggestions first? And by the way, I love that there's just a bunch of math nerds on here. What a great community of us math people that are on here. Just solving integrals. How cool. Okay, someone said an easy trig identity. I think so too. Of course, that's what I'm here for. I'm here for you guys. So sine squared plus cosine squared is an identity. That's literally just 1. That is going to be 1 over e to the x plus 1. That's really nice, isn't it? All right, looking at the chat, I'm trying to see what else you guys would do. Yes, Pythagorean identity, that's what it is. Ooh, natural log of 1 plus e to the x. I actually don't know if that's going to be the correct answer. I actually don't know. But we should definitely take the derivative of that. Actually, if you take the derivative of that, ln plus ln of 1 plus e to the x, it's going to be e to the x over 1 plus e to the x. So it might be a little difficult. Ooh, so Vlad said multiply top and bottom by e to the x. Krish said common denominators. So you could do common denominators, but one cool thing that we can just do is, you know what? Because that common denominator, we want it to be e to the x, why don't we just multiply both the top and the bottom by e to the x? And this is what we're going to get. E to the x over, on the bottom, when we distribute that e to the x to that first fraction, that's just going to be 1 plus, and then now we're just going to have e to the x. Oh, shoot, I doubted you. Who was this? Someone already gave the answer. It was Reef47632. I doubted them. Sorry. But I think you're going to be right. Because now what we have is we have a beautiful integral where we can make our u that bottom value. So, Krish, common denominator, could have worked. That's totally fine. We just tried to do it in a fewer steps, I would say. So let's go ahead and make our u equal to 1 plus e to the x. Du is equal to e to the x dx. And one thing I love to do is I just like to isolate the dx so that I have du over e to the x is equal to dx. And so now we're going to have e to the x over u times the dx value, which is our du over e to the x. Nice. Look at that. That cancels out. So now we have 1 over u du. And now we're just going to go ahead and take the integral of that, and that is a very common integral, and that's just natural log of u plus c. And we already know that our u is going to be 1 plus e to the x. So let's go ahead and do that. Awesome. That I agree. Yeah, because if we don't visualize that, a lot of people just say, well, just, try to think like if the du and the e to the x is down here. It helps to visualize it better. You already said it. I absolutely agree. Okay, that wasn't too bad, I would say. Let's start off with one that looks difficult at first. Thank you, Mad Math. Yeah, we try. You know what? I want to be on here for longer than just an hour. So any support will help, guys. I am here every Tuesday, Thursday, and Fridays, except this Friday, canceled. But if you please want to consider just even subscribing for 1 month, that'll help out a lot. Pretty soon we're going to be doing a derivative fundraiser, so that'll be pretty fun. So continue to follow, continue to support. I appreciate it. So we have integral of root x plus 1 plus x dx. Did I do this one already? I did, huh? Never mind. Sorry. That was the first one that we did. What am I even thinking? This one. So Joshua, I am actually on Zoom. This is a background I created, and I am on Zoom on my iPad here. You'll probably see me right now, and I'm using my Apple Pencil. That's it. U sub for sure, okay? Let's see if that helps, and I think it will. U is equal to e to the x. Du is e to the x. dx. And then I'm going to go ahead and, again, divide the e to the x to the other side, and we get du over e to the x is equal to dx. And so now, continue to rewrite that integral. We are going to have integral of e to the x cosine squared of u times du over e to the x. And what do you know? That e to the x cancels out. But oh no, we still have cosine squared of u. Do we know the integral for that? Hindi, I know. English, not very good. Spanish, not very good. Francois, not very good. And Italian, terrible. No, but really just English and Spanish. Ooh, someone said integration by parts. Tic-tac-toe method, let's go. I hope you got that from my video, because there's a lot of controversy on that. Integration by parts, I'm curious. Integration by parts. So are we saying we're going to separate this? I actually have a different method, but I want to try integration by parts because everyone's kind of assuming that. Because the tic-tac-toe wouldn't really work here. Ooh, someone's saying double angle formulas. That's kind of where we're headed. But I think that's what I would do. But let's try U sub. Or, I'm sorry, integration by parts. Oh, yeah, no. There's no way I can tutor calc in Spanish. I mean, how would you say derivative? Derivado, integral? I don't know. Yeah, that's what we're trying to find. So someone said power reduction formula, but I'm just going to try very quickly to see if we can do U sub. I actually don't know if that will work. I'm just trying not U sub. I was trying to do integration by parts. But going back here, the cosine is cosine squared is a nice formula. So this is a power reduction formula. And let me just rewrite it for some of you guys. Cosine squared of x is equivalent to 1 plus cosine of 2x over 2. This is basically a variation of the half angle formula, but we use this for the power reduction formula. So going back to this problem, we are going to have integral of 1 plus cosine of 2u over 2. And that's just going to help us separate this integral into this. That first one, 1/2, is just 1/2 u. And then here's what I'm going to do. This is just going to become sine of 2u over 4. What I did there is I basically did u sub. I just didn't show the work. I made u equal to my 2u, and I just kind of thought about how that would look like. But the way I like to visualize it is, what would happen if I take the derivative of sine of 2u over 4? Would I still get the same answer? And you would. And so we still have our plus c, guys. Stacey, yes, I do private tutoring, but I am fully booked, unfortunately. I have my pool of students, and so now I'm trying to do a lot of this where I can be online and even help you guys with your homework. So maybe one day we can do like a homework powwow on here where you guys can send me some problems and then I can pull them up on the screen and do that. But, you know, the more followers, the more subscribers we can have in this community, the better I'll be available to help you guys. Going back to this integral, don't forget u was e to the x. So we're going to have 1/2 e to the x plus sine of 2 e to the x over 4 plus c. Boom. There you go. We have our integral. How nice is that? Oh, you should definitely try to comment on some of the pre-calc videos that you have or that I have so that you can I can make some for you guys. But yeah, later on, I'm hoping that I can have like a homework powwow, you know, where you guys can send me your stuff and I can pull them up on the screen and do it together. But until then, we're here. We're doing this together. We work on stuff at the same time. So that's a good question. Why wouldn't integration by parts work? Let me just try that. So we were here. I actually don't know. So we were basically working with this problem. So I'm assuming, Samuel, email me that problem. You can go to the link in my profile. If we try to use integration by parts here, I'm assuming, actually, let me change it to an x so we can use the u. So u would be cosine squared x. I mean, it has to be. Du is 2 cosine x sine x. Ooh, that one's kind of nice because this is a double angle double angle formula. So dv is equal to just dx, and then v is equal to x. So now using the integration by parts, this is going to be x cosine squared x minus integral of x times 2 sine x cosine x. So I think that's the issue there, that when we try to integrate this second part, we still have the x and then we have this value, which we can technically do. I mean, why not, right? Because this will be x cosine squared x. Let me just rewrite this. This is going to be just some x times sine of 2x. So I rewrote that 2 sine x cosine x as a double angle formula. And technically, we would have to do integration by parts here. So this is dx, dv is equal to sine 2x. V is equal to 1/2, negative 1/2 cosine 2x. Again, I'm just doing this very quickly, just because Handyman was asking a question here, and I'm just trying to understand it myself. And this will be negative 1/2 x cosine of 2x, and then plus integral or minus integral of cosine of 2x dx. Oh, so you technically can. You just have to integrate that last part using u sub, and I think you're going to get your answer. So yes, you're absolutely right, Handyman. You could absolutely use integration by parts here. Not the easiest or like the best way, but still works, and that's the cool part. So if you visualize it, just run with it. So the tic-tac-toe works when you can integrate or take the derivative of something and then take the derivative of something, and then at the same time, you can take the integral of something. Let me just show you what that tic-tac-toe method means. Everyone calls it the tabular method. It is the DI method. You're 100% correct, but I just like the tic-tac-toe method. If you guys have seen the movie Stand and Deliver, that's exactly where it's derived from. But it looks a little bit like this. So let's just say, for example, I have x squared, and then I have sine of x. So you 100% can use integration by parts here, but we're going to use that tic-tac-toe method. We're going to take a value that we can differentiate and that we know we can differentiate constantly or take the derivative of until we get 0, and this is the case. So now we have x squared, 2x, 2, and then 0. Notice that I just took the derivative. Start off with x squared, then 2x, and then 2, and then 0. And then we're going to take the sine of x. We're going to take the derivative of that, or integrate, I'm sorry. And this is going to be negative cosine x, and then negative sine x, and then cosine x. And we're going to start off with putting our signs, plus, minus, plus, minus. what you're basically doing here is you're doing a shortcut to integration of parts because you will have to do it constantly if you did this or if you didn't follow this method. Oh, yeah, Vanessa, thank you. Yeah, you can usually use, so I guess basically if you have a polynomial, because you can take the derivative of that, you're going to eventually get 0. I think you're right. The algorithm knows, Yas. Okay, so here's where the tic-tac-toe comes from. You're going to start off with the plus. You're going to go to the x squared and go diagonally downward. That's the tic-tac-toe. Obviously, there could be more, but just this is a great way to remember this. So you just multiply these. So this is going to be negative x squared. Whoops, I'm still in a highlighter mode. Negative x squared cosine x plus 2x sine x plus 2 cosine x plus c. Nice. That is the tabular method, aka the tic-tac-toe method, aka the DI method. Oh, Samuel, I see the problem. So, okay, so as you guys, Samuel just sent us a problem for us to do, and it was informs a pile such that the radius is always half the height. Oh, I love these. Okay, so very quickly, we're going to go to a related rates problem because Samuel was very much requesting this real quick. So let's just, I'm just going to show you guys how this works. You have sand that's being poured, and it's creating this shape of a cone. And the grain is falling at a rate of 8 meters cubed per minute. So that rate is technically our derivative of the volume, 8 cubic meters per minute. And they tell you some other clues. They tell you that the radius is half the height. So radius is equal to 1/2 the height. And now they want to know how fast is the height of the pile increasing when the radius is 6. So we need to find dh dt when r is equal to 6. I know, how funny. We were in integrations, and now we're just kind of doing a quick related rates problem. And this is the way we're going to solve it. So we have to remember the formula that involves all this. It's a volume of a cone, so we're going to use volume is equal to 1/3 pi r squared h. Now look at this. They give us the rate of the volume. We need to find the rate of the height, but we don't know anything about the radius. So when this happens, because we don't have a dr dt, what we need to do is we need to rewrite our problem just in terms of the h. Radif, I think it's totally unrelated. Or I don't know, maybe. I mean, I try to eat as healthy as I can, but I don't know. I don't know how to argue that. But I will suggest eat your fruits and vegetables. Come on. It's a no-brainer. Okay, so back to this problem. Again, we want to rewrite this in terms of just h because we don't know anything about dr dt because I know that I'm going to have to take the derivative of this. So now that we're going to have volume is equal to 1/3 pi. Remember the radius? They told us that it was half the height. Well, that's exactly what we're going to plug in for our radius. And we're going to square it times h. So now we're going to simplify this a little bit. This is going to become 1/4 h squared times h. And maybe simplify this a little further. We can multiply the 1/3 pi times a 1/4. And that'll give us 1/12 pi h cubed. And now we can go ahead and take the derivative of this. But don't forget, we're doing related rates. So when we take the derivative of the volume, that's 1 times dv dt equals, now we're going to take the derivative of the right side. This is just h. Pi is just the constant. So this is going to be 3/12 pi times h squared. And now we have to include that dh dt. Okay, so if we simplify this, this is just dv over dt is equal to pi over 4 h squared times dh dt. I'm not even going to put a parenthesis. I'm just going to put dh dt. That's what we need to find. So we know that the volume is 8. So we're going to plug that in. 8 equals pi over 4. We don't know the height, but we do know that the radius is 6. So we're going to use this equation up on top. 6 equals 1/2 h. So that means that the height is 12. So we can go ahead and plug that in. So now we have the height, which is 12 squared, times dh dt. And let's simplify this. This looks like it's 144 divided by 4. And I know that could be simplified or divided by 4. So that's going to be 36 pi dh dt. And then we're just going to divide everything by 36h or 36 pi. So 8 over 36 pi is equal to dh dt. And this could simplify to 2 over 9 pi is equal to dh dt. That is how fast the height is changing. All right, Samuel, hope you got that. If you didn't, there will be a replay that I will post on my YouTube. So if you guys miss out or if you guys need to leave, you're more than welcome to come back and visit that. Okay, let's go back to the integrals. What do you guys think? So let's go ahead and try. I actually don't even know what to do here. So let's go ahead and see if you math nerds can help me with this. Cotangent x dx. Samuel, the best way you can get better at these is just practicing. Related rates are a problem, but I think the biggest takeaway there is that we didn't have anything for drdt. So immediately when they told us that clue that r is equal to 1/2 h, I knew I had to change my equation for the volume. Ahmad, none of this is useful in real life. Oh my goodness. If you go on to STEM, or if you're trying to, understand Fourier series, if you're trying to be an engineer, I mean, this is incredibly helpful. Someone say grouping like terms. Okay. What do you guys think? Like terms. So I'm interested, Chico, what do you mean by grouping? Ahmad. I don't know. Bro, engineer, you're not using this? I'm a little concerned. What city are you working in? What engineering field are you in? Because I'm a little concerned. Okay, so someone said change everything to cosine and sine. Melonhead. Let's do it. So let me just make sure I rewrote this correctly. So cosine is just cosine, plus cosecant is 1 over sine, over cotangent is sine over cosine. Let me know if I made a mistake there. I wrote cotangent. Oh, software engineer, bro. Well, there you go. But this helps you in logic. I mean, I'm assuming you took some calculus, and that was logic skills, algebraic skills, learning that stuff. Software engineers coming in here to flex. Come on. Okay, did I mess that up? Someone said cotangent is cosine over sine. Cosine over sine, exactly. You guys see that? I made a huge mistake. I wrote cotangent as sine over cosine, but that's for tangent. Awesome. So it's cosine over sine. And now let's go ahead and rewrite this. We have a denominator of sine on the bottom, or for both of them technically. So I'm just going to multiply both the top and the bottom by sine. So now let's see. So now this is going to be integral of cosine x sine x plus sine x all over cosine x dx. Still not too bad. Euler's method, yes. 1 plus tan. I think, oh, there you go. Elijah was saying that this is going to be 1 plus tan. Let's talk about why they said that. Take the cosine out. Ooh, we can do that. So you know what we could do? We only have one value being divided here. So we're going to go ahead and rewrite this all underneath one denominator. And some people might already do this in their heads, and that is completely fine. I am just trying to show the work for the rest of the math nerds that are on here. Yes, it's going to be, oh, someone said +1. Uh-oh. Thank you. Who was that in the very beginning? Ben, Jason, Carlos, Jack. Yes, Ben again, +1. Let's change that. You guys see that mistake? That's what I get for trying to read the chat at the same time. When we distributed the sign into that 1 over sign, technically the sign on the top and the bottom cancels out. So let me just rewrite this. I'm going to remove that sign, and technically that's a +1. And so that tells me that this fraction should be 1 over cosine. I wrote it there in red so you guys can see where I changed that out. Thank you, everyone. Yeah, see, I'm not very smart. I'm just on here talking about integrals. I just like the algebra behind it. It's like fun puzzles, but come on, I make mistakes sometimes too. All right, so that first integral now becomes sine of x plus 1 over cosine x. Ooh, and now we have an easy integral to take care of. Sine is just negative cosine plus that last one, 1 over cosine, is just the integral of secant. So that's just going to become natural log of secant x plus tan x. Boom. There you go. Pretty nice. What if you try use it for the last step? Are you trying... Oh! If you try USA for the last step, it wouldn't work. That's one of the basic integrals for natural log. You know, maybe I can save that. What do you mean by non-elementary integrals? I can try to do that, but I guarantee the number count is going to go from 100 to like 5. Because every time we do some crazy integration, people just bounce. Okay, here's one that I have. Let's go ahead and try this one. Integral of 1 plus, so we have root over 1 plus root x dx. Okay, and sadly, guys, this is going to be our last problem. I am going to have to head out after this. Hope that's okay with y'all. Noah said, can you do trig sub? I don't know. I'm curious. Yamez, I actually solved that 1 over x cubed plus 1. I solved it. And if you see it on my YouTube channel, it is a replay of that. It is, I think, the last live that's on there. So I solved it, and I use Euler's identity, and I use Euler's method. I don't know if we can do this with U sub. I'm just going to try it. All right. So people say U sub. I mean, well, what will my U sub be? So you want to make, should I make the entire value underneath that square root of U sub? Someone said, can you make x is equal to tangent? Wouldn't that give us 1 plus root tan x, which is kind of crazy. U is equal to root x. Let's try that. Thank you, Melonhead. U is equal to root x. I like that. Better yet, just every time I have the root, I don't like to deal with it so much. So I'm just going to square both sides to get u squared is equal to x. And then check this out. I'm going to start taking the derivative. So 2u du is equal to dx. Let's talk, we'll talk about what that's going to give us in a second. And now we can go ahead and rewrite this integral. We have root 1 plus u, that's still the value, times du. Let's just rewrite this. This is 2u root 1 plus u du. And you might think, still doesn't give us much there. But let's go ahead and do one last thing. Maybe I could have done this in the very beginning, but I'm just going to make another u substitution. I'm going to call this w substitution. You know, Krish, I feel like I could. I think it's usually when I take the square root that I'm very hesitant with. I feel like typically this is okay. So yeah, I'm going to take out that 2. So let's go ahead and do w is equal to 1 plus u. dw is equal to just du. You're going to see why I did that. So back in our integral here, we're going to remove the 2. So the 2 is on the outside. U times integral of w. But now don't forget that since w was equal to 1 plus u, w minus 1 is equal to u. So now we have 2 times integral of w minus 1 times root w dw. And now I can just distribute that root. So this is going to be u to the 3/2 minus w to the 1/2. I said u to the 3/2, but it's w to the 1/2. And now I'm just going to go ahead and integrate this using power rule. So I have 2 u to the 5/2 divided by 5/2 minus w to the 3/2 divided by 3/2. And I keep saying u, but I mean w. My bad. Okay, so now we have the plus c. Let's go ahead and rewrite this just a tiny bit. So this is 4 over 5 w to the 5/2 minus 2/3 w to the 3/2. And don't forget that w was equal to 1 plus u. But then u was equal to root x. So w is equal to 1 plus root x. So now we have this beautiful integral at the very end. 4/5 1 plus root x to the 5/2 minus 2/3 1 plus root x to the 3/2. And for some people saying that this is easy, that's great, because we are pulling these problems from the MIT Integration B practice, or the qualifying test. So that's kind of cool. Killian said it's incorrect. All right. I am going to have to leave, unfortunately, but if you guys feel that it's incorrect, please watch the replay and let me know what it is. Let me know in the comments in one of my videos that I have on my TikTok or my Instagram or my YouTube. Rich, this is technically, yeah, you can say this is Calc 2. This could also be Calc B because we're taking the integral. 4/3, did I not distribute the 2? Oh, you're absolutely right. Thank you, Samuel. Thank you. There you go. I solved one problem, and then you solved one for me. So basically what I should have done is I'm going to circle this, highlight it in blue. That 2 should have been distributed to this part. So I didn't distribute it here, so this 2 there should have been a 4. And so this 2 should have been a 4. Thank you. No need to have the W. I absolutely agree. I should have done it in the beginning. But, you know, when I started off, I did U thinking that I will be fine. And then I realized, oh, I have to redo that. So I didn't want to erase it. It just goes to show you could have U, then W. I mean, you could have done another substitution if you wanted to, a Z substitution. Anyway, guys, this is technically a little shorter than usual. Actually, no, it's about the same time. It's about an hour. But I'm hoping that I can stay on longer in the future. So if you like what I do, please consider subscribing. It could be one time, or you can go ahead and follow me here on TikTok, follow me on Instagram, subscribe to my YouTube channel, or buy any of the books that I have in the link in my bio. The more support, the more I could be on here and help you math nerds. Rich, I got these from the MIT Integration Qualifying Test. Anyway, guys, I'm going to go ahead and take off. Yes, you could expand it. I'm not even going to try to do that. But I'm going to go ahead and take off. I'm going to see you guys Thursday. I believe that's where we're going to do some U substitution. But if you guys have any requests, and if I continue seeing these, let me know in the comments or email me with things that you guys want to review on Thursday around this time. And that's going to be all for this week. All right, guys. Well, I hope you guys have a great rest of the week. And I'll see you guys Thursday, same time. Take it easy.